We are finishing up 1-1 on angles, and we just said that standard position is when an angle is placed with its vertex on the origin and initial side on the x-axis. So if I have a coordinate plane here, an angle in standard position is going to look just like this. Vertex here, its initial side will be right along the x-axis. Trying to make it bold so you can see it. Okay, so there's its initial side, and then the terminal side could be anywhere, wherever it lands. But that we would refer to as an angle in standard position. Okay? Nice and easy. Vertex at the origin, along the x-axis, and then we would rotate up to get whatever angle we want. Okay, let's flip to the next page. Now we have these things called quadrantal angles. What word do you see in quadrantal? Yes, quadrants, right? So quadrantal angles, these are simply an angle in standard position with its terminal side on the x or y axis. So for example, if you think about this angle, if it's in standard position, it'll have its vertex here, initial side along the x-axis. What's the measure of this angle? 90 degrees, right? So there's one quadrantal angle. What would you call it if it wasn't there, if it was right over here? What's the measure of that angle? 180, right? 180 is another one. What is it if it's here? Be careful now. Because you are now measuring from here all the way around to here. What would that measurement be? 270, right? 270. And then you could just keep going. If you have a 360 degree angle, it's the same thing as, it's not really even an angle at all, is it? Because you've just made a full circle. You're right back to the origin. Okay, but you could go past that, right? You could do a full circle and then again, and then again, and then again. So your quadrantal angles could keep going. But that brings us to something called coterminal angles. So these are angles whose measure differs, measures differ by a multiple of 360. So let's say, for example, I asked you guys to draw a 40 degree angle. Okay? So it would roughly look like, I don't know, about that, right? Roughly 40 degree angle. But then what if I asked you to draw me a 400 degree angle? Well, if you went 400 degrees, right? Doesn't that mean I'd have to take this, I'd have to swing it all the way around 360 degrees and then 40 more? So wouldn't you end up with the exact same angle? Do you see that? Those are what we refer to as coterminal angles. So 440 degrees are coterminal angles because they only differ by 360. Right? Every multiple of 360 is just a full circle. So what if I asked you to draw an angle that was 760 degrees? Well, 760 degrees. Gosh, let's see. If I did one full circle, 760 degrees minus 360, that gets me, gosh, down to 400. If I did another full circle, that gets me down to 40. So guess what? That is not just a 40-degree angle. It's also a 400-degree angle, and what did I say? 760-degree angle. They're all the same. Do you see that? So that's what we refer to as coterminal angles. Would you ever really want to deal with a 760-degree angle? No, but they do come up. So we'll be talking about them. Like if you had, just off the top of my head, if you have a wheel that's rolling, it may roll 760 degrees, right? It just went 2 full circles and then 40 degrees more. So they do pop up, but I usually don't want to deal with them. Because if it's the same thing as a 40-degree angle, it's a lot easier to just deal with the 40-degree angle, right? Instead of 760 or whatever we're talking about. Okay? So that's where the least positive measure comes in. So this is the smallest a positive angle. Smallest positive angle, coterminal, with the angle in question. All right, so we have a couple of examples here. This says, find the angles of least positive measure that are coterminal with each angle. So my first example is 1,106. You guys probably want calculators today, so if you don't have one, you can grab one over on the cart there, or if you have one in your bag, you're probably going to want one. So go ahead, go grab one if you don't have one. So let's see if we can just get through this section before lunch. How do you think I take a 1,106-degree angle and find that coterminal angle, the smallest one? Any thoughts on how I might get there? Yeah. Not a bad guess, but I wouldn't do that. If you divide it, that I mean, that might help you get started, but I actually think it's more work. I wouldn't divide by 360. What I would do, if I have a large one, like this is obviously more than 360, right? I would subtract 360 until I can't anymore. So I would start off with this one. Gosh, let's see if I try to see if you. Oh my gosh, the sun is killing me with this. Maybe if I do this. No, all right, I'll just do that. So I have 1,106 degrees. I'm just going to subtract 360, and now I'm at 746. That's still too big. I would subtract 360 again. Now I'm at 386. Can I subtract 360 one more time? Yeah, go for it. Minus another 360, and I end up at 26. You're not going to go any more because remember, I want to keep it positive. So I can't subtract another 360 without going negative. So there is my least positive measure of an angle that's coterminal with 1,106. Does that make sense? So that angle is the same thing as a 26-degree angle. Now look at F. F is already negative. What in the world do you think I do with this one? I'm just going to add 360 because I need to get back into the positives. So let's add 360 to that. You guys got 210? So 210 would be my least positive measure. That's the same thing as a negative 150-degree angle. Okay, and then try the last one. And what'd you get? 117, right? You have to add 360 two times on that in order to get out of the positives. Or out of the negatives, sorry. Does that make sense? Okay. So we'll stop here.